Hello geometry students. In this video we are going to talk about quadrilaterals in the coordinate plane. We are going to use slope to distinguish between quadrilaterals and use slope in a variety of different ways to identify what type of quadrilateral a shape is when we know the coordinates. Alright, so since I said slope, let's start off with reviewing about slope. Let's find the slope of this line PQ with these points, P at 4, -2, and Q at -2, 1. Now, there's a couple ways we could do this. The first way I'm going to use is the slope formula. The slope formula is y2 minus y1 over x2 minus x1. Now when we're talking about that, remember we have an x and a y coordinate, so since this is our first one, we'll call this x1 and y1, and over here this x and this y, since they're our second, will be x2 and y2. So when we plug these in, y2 is 1, minus y1, that's a -2. This is always a minus, even if this is a negative, we'll calculate that later, over x2, which is -2, minus x1, which is 4. So when we calculate 1 minus -2, minus negative becomes plus a positive, so we get a +3, and then -2 minus 4 is a -6, and when we simplify this, we get -1/2. Now there is another way that we could do this also. We could graph it, and if you don't happen to have any graph paper handy, I am actually going to use Desmos to graph it. So let's go over here to Desmos. I'm going to put in my coordinates, which are 4, -2, close my parentheses, comma in between for another coordinate, -2, 1. Okay, and now you can see that Desmos has put the points on here for me. I want to have it make the line, so I'm going to click that and just click on line. And then you can see what we have right here, and then we can count. We can make the triangle between these points. We can either go from the one on the left to the one on the right, or the one on the right to the one on the left. If we go, hang on, I'm going to switch back to my other screen for just a second because I have this picture down here, and I can draw on this. If we count down here, if we make this triangle, then this is down 3. So that's a -3, and we go right 1, 2, 3, 4, 5, 6, 6. And so our rise over our run would be -3 over 6, which gives us that -1/2. Now the slope of any line parallel to PQ is going to have that same slope, so it will be -1/2. And the slope of any line that is perpendicular to PQ, perpendicular lines have slopes that are opposite reciprocals. Opposite means we change the sign, so from negative to positive, and reciprocal is we flip this. Instead of 1 over 2, we have 2 over 1, and if it's over 1, we can just write that as +2. Okay, how does that help us with quadrilaterals? We use slopes to identify quadrilaterals in the plane. We check for parallel and perpendicular properties. When we were reviewing just there that parallel lines have the same slopes, and perpendicular lines have slopes that are opposite reciprocals, we can calculate slopes and figure out what type of quadrilateral a shape is. Okay, now this looks like it's complicated, but it's really not. We'll start off by looking at, are both sets of opposite sides parallel? That means they have the same slope. I'm going to go over here to the nose side first, just because there's less. We're going to explore the left side in a moment. If they do not have both sets of opposite sides parallel, we check for one set of parallel sides. If they don't have any parallel sides, then it's just a plain old quadrilateral. If it has one set of parallel sides, then we're talking about a trapezoid, and we look to see if the non-parallel sides are congruent. If yes, it's isosceles trapezoid. If no, it's just a plain old trapezoid. Now let's go back up to the top. If we had both sets of opposite sides parallel, then we've got some type of parallelogram. Then we would check to see if our intersecting sides are perpendicular, and we would follow on from here. If the intersecting sides are perpendicular, we would check for the slopes of the diagonals. Actually, even if the intersecting sides are not perpendicular, we would still check for the slopes of the diagonals. We're going to do a problem, and we're going to come back and refer to this flow chart here. Okay. So quadrilateral ABCD has these coordinates. Let's construct that in the plane. Okay, so I'm going to draw that. A is at 4, 7. Remember, x coordinate comes first, and then y coordinate. So here is A is at 4, 7, B is at 9, 7, C is at 6, 3, and D is at 1, 3. I'm going to connect these, see if I can make it look decent. Okay, here's our shape. Pretend those lines are straighter. And we want to figure out, is this a parallelogram, rectangle, rhombus, square, trapezoid, or just plain old quadrilateral? So let's find the slope of each side. Okay, I'm going to calculate, first of all, I'm going to calculate the slope of this left side, AD. I'm going to go up 1, 2, 3, 4, and right 1, 2, 3. So that slope is 4 over 3. I'm going to check the slope of the one that's opposite from now, CB or BC. And again, I'm going up 1, 2, 3, 4, and right 1, 2, 3. So that is 4 over 3. These are the same slope, so these sides are parallel. Let's check the other ones. How about AB and DC? Well, both of those are just horizontal lines. So when we check this, how much are we rising? We're not rising any. So our slope of our horizontal line up here is 0. And the same situation with this bottom line down here, DC, that slope is 0. These two line segments, they are parallel. So we have both pairs of opposite sides parallel. We have some type of parallelogram. Now let's check to see if the intersecting sides are perpendicular. Well, they sure don't look like it, but let's look at our slopes just to make sure. If they were perpendicular, they would be opposite reciprocals. 4 over 3 and 0 are not opposite reciprocals. So these are not perpendicular. Okay? They are not opposite reciprocals. I'm just going to abbreviate that. Now let's look for the slopes of our diagonals. Okay, so our diagonals, we've got DB right here. This slope for DB going up 1, 2, 3, 4, and right 1, 2, 3, 4, 5, 6, 7, 8. All right, 4 over 8. We can simplify that. It's 1/2. And when we calculate the slope for AC, okay, this one's going down 1, 2, 3, 4, and right 1, 2. So down 4 and right 2, that simplifies to give me a -2. Are the slopes of these diagonals perpendicular? Positive 1/2 and -2, yes, they are opposite reciprocals. All right, so what type of shape do we have? Let's go back to that flow chart for just a second. Okay, so first it asks, are both sets of opposite sides parallel? Yes, so we come over here. Now we check for are the intersecting sides perpendicular? No, they were not. We check for are the slopes of the diagonals perpendicular? Yes, they were. That means we have a shape that is a rhombus. And any time that we have the coordinates, we can find just the slopes and go through that process and determine what it is. We could also use some information about the distance formula or midpoint sometimes, but slope is probably the easiest, most straightforward way to do that. Just calculate your slopes for everything and then check to see if we've got things that are parallel or things that are perpendicular. Okay, now let's talk about finding the missing coordinate. Given parallelogram ABCD, okay, we've got the coordinates for A are at -2, 1, B is at 1, -3, and C is at 4, -1. Find the coordinates of D. That would make it a parallelogram if D is in the first quadrant. So our quadrants, remember they start up here. This is quadrant 1, goes over here, quadrant 2, down here is 3, and down here on the right is 4. So we are looking at, for the first quadrant, we're talking about somewhere up in here. Okay. So to make this a parallelogram, then we're talking about a point somewhere in here. I can tell it's going to be around here. Let's see, how could we do this? There's more than one way that we could do this. What I'm going to do is I'm going to draw in my line right here, BC. I'm going to do that slope and go up 1, 2, and right 1, 2, 3. So do the same thing up here for A. Up 1, 2, and right 1, 2, 3. Now this, when we connect these points, gives us our parallelogram. And that would put D at the point 1, 3 in the first quadrant. But we could also draw a couple of other parallelograms with these same coordinates. What if we wanted to know about D in the third quadrant? So the third quadrant is down here. So if we wanted to draw it in that way, we'd be looking at a coordinate somewhere over in here. And then I want to count, this time I want to go a couple different ways we can do it. Let's check from C to B. I'm going to go my slope here. I'm going down 1, 2 and left 1, 2, 3. So we'll do the same for A. Down 2 and left 1, 2, 3. And that puts us over here at the coordinates -5, -1. But there's actually one more way that we could draw this parallelogram. If D is in the fourth quadrant, which would be somewhere down here, then we have, okay, this one's a little bit trickier to figure out, I think. What I would do here, I'm going to connect my A and my B. I'm going to find that slope. Down 1, 2, 3, 4, and right 1, 2, 3. We'll do the same thing here. Down 1, 2, 3, 4, and right 1, 2, 3. This gives us D over here. Oh, my lines are not drawn very well there. You can always check to make sure that you have drawn those in correctly by checking all of your slopes. Our coordinates here, this would be at 7, -5. Now, an interesting thing is that if you were to plot all three of those parallelograms on the same grid, they would form an interesting shape. So I'm going to put in the coordinates in the first quadrant. It was 1, 3. And our, I want to draw it in a different color. And our shape looked like this was our parallelogram. And then our third quadrant was -5, -1. That gave us, when we drew this, and then our fourth quadrant was at 7, -5. When we drew that one in, the shape that we get if we were to connect all of those points right there, you would see that we actually get a triangle. So when you draw in all of the ways that you could make a parallelogram, we get a triangle. All right, there's some practice problems in Desmos about how to identify what shape a quadrilateral is by using that flow chart. Okay, I'll see you later.